All right, I welcome you back to this session. And in today's lesson, we are going to look at balancing redox reaction. For those who have never heard of me, I'm Chutakunda, coming from the Abundance Academy. So in today's lesson, as I said, we are going to look at the balancing redox reactions. So in doing so, we are going to look at the question from the chemistry 1000 test 1, which was given. So we are going to balance that reaction so that you understand what is needed for you to get started with redox reactions. So I'm going to take all the important steps that are needed, step by step balancing. Then after I've done it in acidic, I think we'll also proceed to basic media. You should take note that when you're balancing redox reaction, you cannot balance the redox reaction in basic media before balancing it in acidic media. So acidic must come first before you proceed to basic media. Without wasting much of the time, let me share the screen whiteboard so that we can get started in balancing this redox reaction. Right, okay. So now, like we said, we are going to balance redox reactions. So let's get started and say balancing redox reaction. Right. So now, what are we supposed to do? What are we supposed to do? Okay, so now, first thing first, when you're balancing redox reaction, we need to consider some steps. So we are going to follow all the important steps that are needed in order for us to balance this redox reaction. And in doing so, we are going first to look at an example, because it is from the example that we are going to derive all the important steps. So, like I said, we are going to balance the equation which was given in test 1. So the equation was correct. Not necessarily that handwriting. Okay, sorry for that. So we have this. Reacting with sulfur dioxide there to produce sulfate radical there plus chlorine radical there. All right. So now let's look at the important steps now that we need to consider. So now let's start by saying steps to consider. So you can apply these steps to any redox reaction that you need to balance. You can apply all the steps we are going to consider to any reaction that you have been given. So let's begin with step 1. So step 1 says, write the 2 half reactions. So from the given equation, you need to derive your own half reactions. That is, you need to come up with a reduction reaction and as well as the oxidation reaction. Or in simple terms, when they say two half reactions, if you don't know which one is the reduction reaction, which one is the oxidation reaction, what you simply have to do is that you just have to check the reactants that you have. For example, if you are dealing with this reactant, where else can I find proteins? For example, here, so this will produce, this one will produce what? This reactant, product. This sulfur dioxide will also produce sulfate. As easy as that. You can relate in that manner. So the first reaction we have is this, producing chlorine, like that. Then the second one that we have is sulfur dioxide. So sulfur dioxide is producing sulfate like that. So that is the first step. You need to come up with the two half reactions. So these two are the two half reactions that we have here. So those are the half reactions. Then you proceed to step number 2. So step number 2. So step number 2 says balance all atoms. Balance all atoms. All atoms present except oxygen and hydrogen. That's the second step. What that means is that you balance all atoms present, all elements that are in the, those two half reactions, except oxygen and hydrogen. So you don't balance oxygen and hydrogen at step number 2, but you can balance all other atoms. So the idea there is that if you have the two half reaction, for example, you are going to copy the same one that we have. So here, the first reaction we have is that producing chlorine like that. So what in the first half reaction, what we have as other atoms present is basically just chlorine. Oxygen, we are saying we don't balance oxygen at step number 2. So you have to balance it other atoms. For example, in this case, we are dealing with chlorine. So chlorine here and chlorine on the product side must be the same. So in this case, we have chlorine 1, chlorine 2, no need. Chlorine 1 on the other side, no need for us to balance that. But if we had a case where we have chlorine 1 on the reactant side and chlorine 2 on the product side, we would have added a 2 on the reactant side so that you get 2 as well on the reactant side. So since we have 1 to 1 in this case, everything is balanced. You inspect also the second reaction. Sulfur dioxide there producing that. So in this case, we're just going to inspect not oxygen, but we're just going to inspect sulfur. So sulfur 1, again, sulfur is also balanced. We proceed to step number 3. Hope you are following. So step number 3. Step 3, balance oxygen. Balance oxygen, okay, by adding H2O, which is water, to the side with fewer number of oxygen atoms. To the side with fewer number of oxygen atom. Again, what does that mean? So what that simply means is that you check which side has insufficient number of oxygen. So let's look at what we have as our reaction. So in reaction 1, we have this. We have that producing chlorine like that. So now you check which side has insufficient or fewer number of oxygen atoms. So in this case, the product side doesn't have any oxygen. So it is the side where we are going to add water. Is that okay? So we are going to add water to the side where there is no or insufficient oxygen. So in this case, we have 3 oxygen here. So which means we need to have 3 oxygen on the product side. But we are told that to balance oxygen, you need to add water. Now, you should take note that the number of water molecules added on the side where it is necessary must be equal to the number of oxygen atom present on the side where there is oxygen. Why? Because we only have one oxygen atom in water. So in this case, we are going to say plus how many water molecules. So we are saying we balance oxygen by adding water. Now, how many oxygen atoms are we going to add? In this case, once you add water like that, you need to count how many oxygens we have on the other side. So in this case, we have 3 oxygen this side, which means we need to add 3 water. The reason is that this in water, there is only 1 oxygen atoms. So but by adding 3 water molecules, we are saying we've added also 3 oxygen, which is equal to the oxygen on the reactant side. So we proceed to the other reaction. No need for you to balance hydrogen at this stage. You just proceed to the other side, to the other reaction. Once you balance oxygen in the first, that's all. That is for step number 3. So again, for the other step was sulfur dioxide like that, producing sulfate like this. Now, in this case, we have, we have 4 oxygen atom on the reactants on the product side, and we also have 2 oxygen atoms on the reactant side. So we are going to add water now to the side where there's fewer number of oxygen. In this case, it's the reactant side. So we need to add water here. So say plus water. But again, the question is how many water molecules are we supposed to add? In this case, we need to have 4 because on the product side, we have 4 and here we have 2. So we add 2 water here. So once we add 2 water here, which means we have added 2 oxygen plus that, we have 4, also 4. In this case, oxygen is balanced. So that's how you have to check. That's okay. Let's proceed and go to step number 4. So step number 4, we need to balance now hydrogen. How do we do that? So balance hydrogen by adding H plus. In this case, you're not going to add water, you're just going to add H plus to the side with, okay? So we are going to add basically to the side with less hydrogen, So what are we supposed to do? We are working with these 2 half reactions, so you need to copy what you have there on top. That's the first reaction producing this. This is what we have as the reaction now. Remember that at each stage, the reaction changes. So you need to continue with the recent worked reaction. So in this case, what we know is that in the first reaction, we have 6 hydrogen. So which means we need to add 6 H plus. Are we supposed to add 6 H plus? Yes, we need to add 6 H plus because we have 6 hydrogen on the product side, so we need to add 6 H plus. Okay. So we've added 6 H plus, meaning that hydrogen on the product side, we have 6, and on the reactant side, we have 6 as well. Well, we proceed to the other side. Remember that you are not balancing anything apart from hydrogen in this stage. So we are we have also this reaction plus 2 water to produce sulfate. It's O4 negative. So we are going to add H plus on the reactants on the product side because we have hydrogen on the reactant side, so we need to add on the product side. And how many are these? They are basically 4, which means we need to add 4 H plus on the product side. At this stage, you have balanced the hydrogen. Don't balance anything else apart from hydrogen and oxygen. I mean, at step 4, only hydrogen must be balanced. Let's proceed and check step number 5. So, step number 5, what are we supposed to do on step number 5? So, on step number 5, we are going to balance the charge. Okay? Balancing the charge on step number 5. Now, how do we balance the charge? So we balance the charge by adding electrons to the side with higher higher oxidation state. So step number 5, we are saying balance the charge by adding, by adding electrons to the side with higher oxidation state. So what that means is that you need to check the oxidation state on the product side and the total oxidation state or oxidation number on the reactant side. So, for example, we have this equation number, the first equation here. Observe that on the product side, we have the oxidation number, total oxidation number, because here on chlorine, we have -1, on water, we have 0, so we have total oxidation number of -1. So the oxidation number on the product side is -1, and the oxidation number on the reactant side is basically, so here how do we count? We have this negative positive here times the coefficient it is holding there. So 1, this is +1 times 6, we have +6. Then here, the total oxidation number being given to be -1. I mean, that's the oxidation charge. It is not neutral, but it is negatively charged, which means it has the oxidation number of -1. So we have to add now, which means the overall charge on this is -1 and the overall charge on H is +6. So +6 plus -1, what we are getting is basically -5. So observe that on the reactant side, we have the oxidation number of on the product side, we have the oxidation number of -1, but on the reactant side, we have the oxidation number of +5. But the question is, we need to balance these charges. We have the charge of -1 on the reactant side and the charge of +5 on the product side. Now we have been told that we can only balance this by adding electrons on the side with higher oxidation number. So in this case, the total oxidation number on the product side is +5. So this is the side where we are going to add electrons. But the question is, how many electrons are we going to add? What you should remember is that an electron is negatively charged. So every time you add electrons, we are increasing the negative part, not the positive part. So if we add 5 electrons on the reactant side, 5 electrons, which means we have added negative 5 because it's negatively charged, which means negative times 5 is negative 5, plus the charge on H here is what? Positive 6. So we have plus 6 minus the charge on this species here is negative 1. So which means minus 1 here. What are you basically getting? You are getting the overall charge of 0. But we have the overall charge of negative 1 on the reactant side, which means again the charge is not balanced. Now the question is, how many electrons now are we supposed to add if not 5? So which means you need to add more electrons so that when you add the total charge on the reactant side, you are expected to get negative 1. So that negative 1 on the reactant side is equivalent to the charge on the product side. So we are going to add 6 electrons. So if we add 6 electrons, which means we have added negative 6 plus 6 minus 1, what we are basically getting is negative 1. So which means on the reactant side, we have negative 1. Also on the product side, we have negative 1. In that reaction, the first one, it is balanced. So let's do that. We are going to add, so in equation 1, we are going to add 6 electrons. We complete the reaction, 6H plus this producing, what way are we getting? Chlorine plus 3 water. The question is, in this equation, is the charge balancing? Yes, on the product side, we have negative 1. Also, if we add this side, we have negative 1. The charge is balanced. We go on the second equation. So the second equation, okay. So the second equation, it is here. What charge do we have on the reactant side? Well, the reactant side has sulfur dioxide has no charge, water has no charge, so the charge here is 0. And what do we have here? The charge is positive 2. The total charge, because negative 2 plus 4 here, we have negative, we have positive 2. So now we have 0 on the reactant side and we have positive 2 as the overall charge on the reactant product side. What are we supposed to do? We need to add 2 electrons on the product side. Why? Because this is where we have higher charge. The reactant side has 0 and we have positive 2. So we need to add electrons to the side where there is higher charge or higher oxidation number. It's okay. So now, if we add 2 plus here, we have 2 plus, 2 electrons plus 4 plus, we have positive 2. Positive 2 plus 2, we have 0 oxidation, and also this side 0. So which means the charge is also balanced. So now we are going to add on the reactant side, we don't have to add anything. This side is okay. And we are going to have this on the product side plus 4H plus 2 electrons. So at this point, these two have reaction, the charge is also balanced. Since the charge is balanced, okay? Since the charge is balanced, well, at this point, you can even tell which one is the reduction reaction, which one is the oxidation reaction. How do you tell? Well, it depends on where you add electrons. So if you add electrons on the left-hand side of the reaction, or rather on the reactant side, then that reaction is the reduction reaction. Every time you add electrons on the left-hand side of the reaction, then that reaction is basically the reduction reaction. And if you add electrons on the product side, then the reaction is the oxidation reaction. Is that fine? So that's what it means. So in this case, the second reaction is the oxidation reaction. The first one is the reduction reaction. So now we go to step number 6, if I'm not mistaken. Okay, so yep, perfect. So let's go to step number 6. Step number 6. So step number 6 is saying we need to balance the electrons by exchanging them. So we need to balance the electrons by exchanging them and multiply the reaction. Multiply the reactions. What does that mean? Well, what that means is that this, for oxidation, how many electrons have you added? You added 2 electrons. And for reduction, how many reactions did you add? You added 6. So what that means that we are going to exchange this reaction and multiply the reaction. I mean electrons and multiply the reaction. Well, we mean this. The equation, this is the equation. We have 6 electrons plus 6H plus K to produce this plus this. Now, at the far end of the reaction here, what it means is that when they say exchange, the electrons that you added in the oxidation reaction must multiply the first reaction. So in this case, we put 2. This 2 is coming from the oxidation reaction electrons that you added. So these 2 multiply everything in this reduction reaction. Same applies to the other reaction, which is sulfur dioxide. Times 2H2O and produce this. This is what you're going to produce, plus 4 water, H plus 2 electrons. Then for the second reaction, you're going to use these 2 electrons, 6 electrons that you added in the reduction reaction and multiply this. So which means this 6 must multiply everything here. But again, when it comes to multiply, how do we multiply these electrons? So at that point, before multiplying, the electrons must be in their simplest ratio. So in this case, we have 2 and 6. So this is not the simplest ratio. 6 can be divided into 6. 6 can, 2 can go in 6 rather. So we can divide this. We have 1 and we have 3, which means you are going to multiply this reaction with the ratio of 1 to 3. So when that happens, the first reaction will not change. Okay, the first reaction will not change because we have 1. So when 1 multiplies that, you have the same reaction, but the second reaction will change. So we are expected to get this reaction. Okay, let me copy fast and get this. So that's the first reaction. That's the second reaction. 3 will be multiplying that. So we are expected to have 3 sulfur dioxide there plus 6 H2O producing 3 sulfate there plus 4 times 3 is 12. So we have 12 H plus and we have 6 electrons now. So at this point, you can now cancel the electrons because they are appearing on both sides. So you can basically cancel them. So that will be cancelled with these 2 electrons. What else can you cancel? If, like in this case, water is appearing on both sides, so you can cancel that. It is appearing in this. So we can cancel that. And when we cancel here, you are expected to remain with 3 water. So now, what's the final reaction after doing that? So the final reactions, you are expected to have. So at this point, you now have to, after you have done the cancellation, you need now to add the two reactions, which means all the products must be on one side and all the reactant must be on the other side. So that now step number 7, add the reaction. Right, so step 7, now after you've cancelled, you go to step 7. So step 7 is add now the two half reactions. So basically that's what you have to do now. So which means you're expected to have 6H plus this is nothing changed on this one. We also expect to have 3 sulfur dioxide and 3 water, because that was made to produce 3 this here plus this here plus what else do we have? We have 12 H plus. This is not making sense because again we have H plus on both sides. So again, it's easy for us. We can simply cancel again. There's no harm. You can cancel the H there, 6H, and when you cancel something here, we expect to have 6H plus remaining. So the final now will be just this. So we say final reaction. We're expected to have plus that. Let me do that quickly. And do that quickly. I do that plus this plus 6 electrons. I mean H plus. Now is the first we need to consider is always we need to now check if the reaction is balanced or not. Okay, we need to check if the reaction is balanced or not. Is the reaction balanced or not? We need to check that. But how do we do that? We're going to do speech by speech. So let's begin. Chlorine, we have one chlorine, excuse me, balanced. We have 6 hydrogen. How many do we have here? 6 hydrogen, balanced. We have for oxygen, how many oxygen do we have? 3 plus 3, we have 6. 6 but plus 6, 12. We have 12, 3 by 4, 12. Balance sulfur 3, sulfur 3. The charge now. The total charge here is -1. What's the total charge here? So this -6 by 3 is -6. Or -2 by 3 is -6 plus 6 here. We have 0 plus -1, we have -1. So negative, everything is balanced. Hence, you can conclude that the reaction is balanced in hence it is balanced in acidic media. So basically, that's all you needed to do with this reaction. Right, so as always, I'd like to leave my contact. This is my contact. In case you need some different and special classes, please feel free to contact me on this line, 0970 94 10 96. So that's my contact, Mr. Kunda. So I'm going to make another video, like always. I'll make another video on, I'll proceed with, I think, the same reaction in different video on how to do the balancing of the redox reaction in basic media. Remember, this one is in acidic because what we have here, H plus, is indicating the acidic part. But if you leave it in OH, then that's the basic part. All right, enjoy your evening, or rather afternoon. Okay, see you in the next video.